All right, welcome. Thank you everybody for getting here. Sometimes the first morning session, the day after the party, is notoriously bad. And look at who made it. Giorgio. Yeah, I'm kind of impressed actually. I didn't think there was a chance in hell you were going to make it. Speaking of the party. My talk this morning is on functional techniques for ActionScript and Flex developers. I named this very carefully. Here's why. Functional programming is as much a religion as any other you've ever encountered in your life. The way that people program, it's actually funny, there was a guy that I follow on Twitter named Mr. Ralph, he's a compiler engineer, and he at one time said, who thought we would have broken down into tribes and worked with each other on the languages we speak to the machines with? And it's an awesome quote, because that's basically what we do. But functional programming is a fascinating and wonderful and interesting way to go about programming. It's been very popular in academia since the beginning of computing. In fact, Lisp, which is one of the earliest implementations of functional programming, was done in '59. The theory behind functional programming, Lambda calculus, was done in the '30s. This isn't new stuff. It's old, but it's also really, really relevant for a number of reasons. There's no way I can teach everything about functional programming or even get into the nuances of it in the course of a session like this. So what I've decided to do is extract a couple of techniques, a couple of things that I actually think are useful to workflow, a couple of things that you can probably incorporate into what you do for the Flash player and show why I think they're interesting and why I think they're kind of relevant. So that's what this is about. Okay? It's about how to take some of these techniques and make them more practical. All right, very briefly, imperative programming is sort of the opposite of functional programming. Imperative programming is mostly what we do every day. We declare variables, we assign them with values, we transform those values, we assign new values. The thing is that imperative programming is very time-oriented. What I mean by that is that something happens here, and then something must happen here, and then something has to happen here. We have to know the order of when things happen, and it's very important. Okay? So if something is happening here, obviously we can't have looked at that data before we assigned it. We can't have worried about what's going to happen here. The concept of, let's say, a race condition, everyone's heard that, which is when we come to the point of we think a piece of data is ready, but it's not ready. It's because everything we do in imperative programming is so time-oriented. Okay? It's step by step. Now, it turns out that's actually very problematic as we go forward into computing. While this isn't as relevant to Flash Player, I think it's relevant in general to understand. Moore's Law, is everybody familiar with Moore's Law? Okay. Moore's Law indicated that processor speed would roughly double every 18 months. Turns out it doesn't anymore. Okay. We haven't actually been doing Moore's Law directly for a long time. Instead, what's been happening is that we've been adding more cores. Okay. Computers today have multiple cores in them, and we've done this because of the fact that we're not necessarily able to keep up with that doubling trend. So to roughly keep computing on that same trend, they've been adding cores. Well, cores are really cool, but cores also mean that you have to do multiple things at once. Okay? You have two different CPUs doing two different things. But with imperative programming, or a programming style that's very important about what order things happen in, we have a problem when we start having two different things trying to operate on the same piece of data. Okay? This is where timing, where locking, where all these things come about. It's the reason that even in ActionScript or JavaScript worker threads, they are very tight and say, well, we can't have shared memory, we can't have these sorts of things, because as soon as we actually have multiple things trying to access the same data at once, we're just causing potentially massive number of problems. Okay, so imperative programming is pretty much the state of the art. Okay, this is what we do for the most part, but the reason today that some of these older techniques are starting to come in and people are going, maybe we have to adjust the way we're doing things, is that in a world where we have multiple cores and multiple things working at once, the idea of doing things in steps and in time order is becoming harder and harder to buy for a long period of time. Okay, it gets very complex. The alternative to that is functional programming. Now, functional programming is about avoiding state. It's about avoiding immutable data. So in a functional program, things can actually be expressed algorithmically. Now, we use the term function all the time when we're talking about programming, but we kind of use it wrong. Technically, when a function was originally defined, we're talking at the beginning of computer science sort of idea, a function wasn't supposed to have side effects. A side effect means that I call it some type of global state changes somewhere. Okay? So when I call a function on a data grid and there's a data provider set on it, I just change some kind of global state. Technically, older programming languages used to break these ideas down into like even procedures and functions. These things being things that updated global state. Functions always having a return value, because they were supposed to only run operate on the things they were given and return a value. Okay? So the hallmark of functional programming is that you have a lot of functions, tiny little pieces, that operate on their data that they're given, and they return something. And you can't tell looking at the rest of the machine if they ran or not. What I mean by that is that I can run this thing over and over again. It doesn't matter when I ran it, because it only works on the things I gave it, and it returns something when it's done. And there's no other effect, no hit in the computer, no other global memory change, nothing else changed. So, while it's hard to get all that together in the right now, the point of this sort of multi-core, multi-processor thing is that if all of our functions just worked on what they were given, and then they returned something, and it didn't matter what state things were in globally, we get away from the idea of time. Because we don't have to worry about did this run before this, because it doesn't matter if they just took what came in and returned what they were done. We can kind of stack things on top of each other and run them at the same time. That's why functionals become so popular in the idea of this multi-core world. Okay, I'm leaving it at that for the moment, but we'll see a little bit as we go forward. It's subject to debate how functional is functional, because any good religion has sub-religions. Within functional programming, there's purely functional, where we can't ever have state or nothing can ever change. And then there's n variations of how functional people want to be. ActionScript has something called first-class functions. It has our ability to create these functions anywhere. When I say a first-class function, what that means is that a function should be like anything else in the system. If I can declare a string anywhere, which I can create one in a method, I can create one in a function, I can create one anywhere. Well, then I should be able to do the same thing with a function. That's what the idea of a first-class function is that I can declare it like any other variable. Since ActionScript has first-class functions, we can do a lot of the functional programming techniques with it, but it's not a purely functional in any stretch of imagination language. But it does mean we can borrow some techniques. And what are they good for? Well, they're particularly good for scenarios where we have complex pieces of data that are being accessed from multiple locations, where we never get into that place where we have time-oriented things, where it's kind of difficult to figure out what's going on. Because again, they sort of get away from time and move back to it. They're also sometimes good for creating syntactically clearer code. We'll talk about that. And that's going to sound really weird because the implementations look stupid at first, but the end result of it actually ends up being kind of neat. Okay, so that's my spiel on that part of it. Really quickly, object-oriented. This is funny because there is so much argument about what this all means. There's really a person that I respect a lot named Mark Labriola. Mark Labriola actually wrote the current version of the JavaScript, of the Java compiler. He's also responsible for Scala, if anyone's heard from him. He has an opinion which I actually tend to follow. A lot of people group object-oriented into imperative and say it's only there, so all object-oriented programming is imperative. He sort of sees that object-oriented programming isn't necessarily functional and necessarily imperative. It's just a technique that can be applied equally well with some rule changes into either of these environments. I tend to agree with him, so I don't see functional in opposition to object-oriented programming. I see object-oriented programming as one sort of overarching theme of what we can do, and below it we can do imperative programming like what we do today, or we can do functional programming. I say that, and it's probably, amongst so many people, extremely controversial, simply because of the fact that there's a certain community that has a backlash against object-oriented, and they throw out imperative, and they throw object-oriented with it. There's all these sorts of infightings and stuff. But it should be about encapsulation. That's what object-oriented programming is. It should be about allowing us to sort of perceive state, which I say because in functional we don't have it. It's not necessarily different. Okay, that is what I'm going to do with slides, because frankly, after that, I just want to talk and code and walk through these things. So I'm going to put together some little pieces here. I'm actually trying to move this around a little because that font and the screen resolution have made that fairly ridiculous. But we'll put that up top so that you guys can hopefully see that a little better. And we'll just look at this little bit of code that we're going to have here. We'll start off small with some pieces, and then I want to build on them, just to kind of show you how functions and something called functional composition, and eventually how something called partial application can build together to make really interesting approaches and programming methods. All right, really simple. It's a starting point. I have a function called print. All it's going to do is take whatever the array I give it is, and it's going to print it all out with line breaks between it so we can see them on different lines. I have an array, and I randomly inserted all the people who were drinking wine with me last night into. And their rough ages, Georgia, you'll be happy to know you're 312. And I've thrown those up here. And optionally some addresses in case we get around to doing something like that. We'll see. And what we're going to do is we're going to use some functional techniques that are here. And actually, it's interesting because when ActionScript was designed, much like JavaScript, it was designed to be able to use some of these techniques. There's actually a lot of hooks into it that we don't realize are there. But we're going to start off with something relatively simple. What we want to do is we have our people array, and if we were to run it right now, it's just going to print this out. It's going to print out individual people and things like that. What we want to do is start by exploring a couple of the methods and a couple of the ideas of what different objects or different pieces of the array class do. I'm going to use this because the array class is actually very similar between JavaScript and ActionScript, and it supports some of these functional ideas. So we're going to kind of start there. Okay? All right. So as a starting point, we're going to take people and we're going to filter it. Now, filter is a method inside of the array class of ActionScript or JavaScript, and it takes a callback function. Okay? And that callback function has a very specific signature and optionally a this print. Now, it is a functional technique, which means that it's not going to change people. Remember, I said that functional stuff isn't about, imperative programming is about the fact that we have a variable, we change the value, we set it, etc. Functional is almost always going to return a new object. So all of these methods are going to return a new array. They're not going to change the existing one. And again, this whole idea of time-oriented, I have an array, I change it, well, that's a time-oriented thing. People meant something different here and here if I change the array. Okay? If I return a new array, I divorce myself from the time in the sense that people meant the same thing always, and this new variable or this new array will mean something else, but people didn't change. Okay? All right. So right now, as a starting point, this thing is going to take a function. I'm going to do some of these things just in line right now so that we can kind of see them. Do them as anonymous functions. Okay? Now, the signature for filter is a little complicated. We're going to just use part of it for right now. So we're going to say what we're going to do is we're going to filter by a person. And actually, there's some other parameters that this thing can take, but we're just going to kind of do a little rest piece, which is basically saying, hey, we're going to take the rest of them, we're going to ignore them for right now. I'm not going to worry about what those are. I just don't want to distract from our example. Okay? Now, the callback function for an array basically takes one of the objects and it's going to return a Boolean. How this thing works is that it's going to call this function for every element in that array. And it's going to say, hey, is this thing supposed to be in here? And if you return a true, the answer is yes. If you return a false, the answer is no, it's not supposed to be in here. Okay? So that's the starting point of what we're trying to do. It's much like the filter function in Flex, although the difference being that the filter function appears to actually modify the array collection itself, not return a new array collection. Okay? All right, we'll start off very simple. We'll say if, or actually, person.age, okay? And if they're less than 100, that'll be true, okay? So what we're going to say is return, we're going to try to say return. Person.age less than 100. And we'll just print this out real quick. We'll take that print method. Okay. Don't get lost in the code of what's going on here. Let's just keep the concept for right now, which is that we're going to take people, and we're going to run this function on it, which filters it down to see if somebody is less than 100 years old, and if so, they're going to be in the array and print it out. So if we run this thing, right now, the only two records that came back were June Hyder and Nick, because those are the only two that I have ages less than 100 now. Okay, so a simple piece, what we've done is we've filtered something by creating a function. All right, now that's interesting, but it can go a lot further because this isn't a lot different than what you did so far. But no, we created a function here. We created a function in line. We tend to call these things anonymous functions in ActionScript, and it's kind of funny because we tend to say that almost with a sneer of like, it's an anonymous function. It's there somewhere. It's actually a really, really powerful piece, okay? Because anonymous functions have something called, or they close round things, or there's a closure. Meaning that they're special in the sense that things that are in scope when this function are created stay in scope. What I mean by that? Well, actually, let's show you what I mean by that. We're going to move into something called a higher order function now, okay? A higher order function is a function that returns a function. Okay? Now, it sticks with this principle, and I'm only going to show it briefly here. which is called application. We'll get to it. What it means is that if I had a function that takes x and y, okay, I could represent that in the same way by instead making a function that takes x and returns a function that takes y. Now, stick with me on this. I promise it's not as bad as it seems. When we go back here, what we're going to do now is we're going to say, well, this was nice, and we put this little function in line. You know, I really want something a little easier than that. So let's go ahead and create something up here. We'll make a private function, and we'll just call it age. And we'll take a num of type number, and it's going to return a function. Okay. Now inside of here, what we're going to do is this. We're going to say return function. We're going to create a function inside of here. And it's going to take a person and our same little thing again there. And it's going to return a boolean. And this time we're going to say return person.age less than, or here we'll actually call it less than age. Okay, person.age less than null. Now looking at that for a moment, actually let's go use it and then we'll look at it for a moment. So we're going to come down here and I'm going to get rid of my function I put in line here, and instead I'm going to say I now want to filter things by something that's less than 50. Okay, the age is less than 50. So if I run this really quickly first, apparently not. We'll go to that in a second. What did I do? Probably spelled something wrong. We'll see in a second here. Yeah, a couple too many prints. Other than that, we'll be fine. All right, so people filter. Okay. Sometimes it's not enough coffee in the world. All right, so good. June is the only one that comes up. So what we've done here is we've written a generic filter in the sense that that filter takes a person or takes the people and it applies something where it says less than age 50. All right, what did I do though? Well, what I said here was I got a function which is going to take a number and it's going to return a function. And that function is going to take the person's age and compare it to the number. Okay, now here's where closures and closing around a function comes in. Whenever I create a function this way, in a functional language or a language that has functional techniques, this function, when it's created, it keeps track of all of the state that was in scope at the moment it was created. Meaning that this variable here, number, is going to kind of forever be known to this function. It's like I wrapped it up in another object, okay? So when this function runs, even though it's independent and it's separate, it's still going to remember what number was when I called it. So I can say things like, if less than age 50, okay? And that created a specialized function which always checked if something was less than 50, okay? Now, I can keep building on this concept and go further and further in how it works. We started with something less than 50. Let's do another one. Let's filter where we have somebody's first name, okay? So we'll do first name, okay? And we'll do a kind of a like, or actually that's what we'll do. We'll do, first name like is fine. It's going to take a person, and if that person's first name, which is a string, in any way in it has name, okay? So in other words, if this name that we pass in, if this part of the name is anywhere inside of first name, it's true. So just going back here for a moment, we'll get rid of less than age 50. And instead we'll actually say first name has JU in it. Okay? So if we run this really quickly, we'll see that we got June and Justin. because of the fact that we just converted and we had something here. Now that's cool, but we can go further. We could, as long as we have functions that take functions, well, why not functions that take functions that take functions? That seems like fun. So let's define a really simple function called or, okay? And or is going to take two functions. And it's going to return a function. And what it's going to return inside of it is something that does this. Return F1 person, okay? Or F2 of person. With me so far? Okay. So now we can come down here and say, well, is their first name June, or is their, what do they call it, LTH? Is their age less than 700? I've created now a compound function, okay? I've created a compound filter function wherein I've actually built on the fact that we've got this condition, and we're going to OR them and pass them into the filter. Does everybody kind of see what I'm doing and how I'm building up things here? Yeah.
Stop me if I didn't hear you coming this later on. Well, when this is compiled, are those functions pretty much statically linked, or are they going to be like literally put on the stack and then interpreted every time?
What do you mean by interpreted? I want to be careful before I answer your question on that, because it feels leading to me. Sure.
Is it going to be in memory where you're actually going to have stacks, like, like recursive calls, like how you can see something like that?
So, I mean, they're functions. They're created. They're no different, terribly different in variables. But once we've created a function definition in what it's going to do, it's simply going to exist for the duration of the time that it's there. I think that's what you're kind of asking. So these functions are going to exist, but a way to think about these in the same way is that it's like objects. It is objects, because functions are objects to us. If we were to create an object that held onto a property so that it had a function on it that compared something, it would be as short-lived as we need it to be, and then the garbage collector would get rid of it. We're doing the same thing here. And in fact, in some ways it can be more efficient, in some ways it can be less. The more efficient part can be the fact that since it's now dynamic memory, these things get garbage collected when they're not being used, which means they're not sitting in a big static lump of code that we have sitting there. Now, ActionScript, to be honest, you wouldn't want to do like 7,000 of these things down, because the ActionScript virtual machine, the ActionScript virtual machine inside a Flash player doesn't optimize these things much more, okay? But there's still interesting techniques and there's still validity behind the idea. And more so, and this is one of those things, there's lots of things you can learn in your career that are applicable in multiple places, and this is one of them. In these techniques that you're looking at now, these are applicable in ActionScript, they're applicable in JavaScript. By the way, they're also applicable in a lot of languages that do optimize the hell out of these sorts of things and make them really, really efficient. So it's about the technique right now. It's about the idea. All right, if I got that remotely close to right, which is a decent chance, we just did an OR function. So this time we got Giorgio, we got June, we got Justin and Nick, because we have the combination of first name and an age less than 700. Okay? So we've started building up syntax from these things. And by the way, we can go further. We'll only go one more step right now. We could just do something as simple as not. Okay? And now we have the ability to say very complex things like, well, where the age is less than 700, let's do that first. Okay? Or they're not. They don't have a first name of June or Jane. Okay? So these pieces build slowly on each other in order to give us a really rich language in which we can actually build. Now we're doing simple logic right now because it's a good thing to learn, but the idea is that we can actually build on these techniques in order to allow us to create a richer sense of how things come together. Okay, this is higher order functions. And now going back for a moment, now that we've seen it, that's what this is talking about. We really needed a function that was going to take a name, okay? And it was also going to take the signature, which the filter function accepted, which was an item and all these other things. We didn't have that capability, right? We don't have the capability of saying, oh, what I'd really like to do is I kind of want to pass in 70 or 700 to the filter function, but then the filter function really wants a function that does all these other things. We don't have a way to express that. But what we can realize is that, well, what we need was a function that took these two parameters, and we didn't have one. So what we created was a function that took one and returned a function that took the other, okay? So we created a function that took num and returned a function that took what was next. That's what partial application, that's what this was about. Okay, now just a couple more things once we're in here with these APIs. It gets kind of fun because there's a bunch of other ones that, as far as I can tell, most ActionScript and Flex devs never use, and they're terribly useful, especially when you start doing things like this. Like, let's take, for instance, map, okay? We can do other things with this. Map is a function that takes on an array, runs a function on every element, and then returns the element that were returned from those functions. So let's see, as an example, we have these complex objects, right? Let's write ourselves a little function here. And we can do these in line too. And we'll take a person again. And we're going to, again, of course, return a function, right? I should just copy this because it would make my life a little easier. That's okay. All right, so our private function is going to take a person. We will call this one, for right now, name, okay? Let's call it name. Or we'll call it get name. Okay, so what name is going to do is we've been doing one that return booleans so far. We're going to do one now that returns a string. And all we're going to do inside of here is return person.name. So, or person.first name. Okay. So what map does is map takes a function, and map is going to return an array for us. We need to stop doing that. Map is going to return an array for us of whatever this function returns, which means when we run this and we do it right, we get a different result than whatever the hell I just did. Actually, we can make this simpler. Let's right now. One print. Sorry, 1 second. There we go. Okay, so what we're doing, map, is this. We just went through that array and we returned all of the first names. We did that because of the fact that we provided to map a function which grabbed a piece of data we wanted out of the object. So map built us a new array of things. So hey, anybody ever have to do something like, I don't know, iterate through a whole bunch of objects and convert them from one type to another to have to go through and do all these things? Well, gee, guess what? That's what map does, but none of us ever use it. If we would do this, let's say, okay, well, we have a first name and a last name, but really we just wanted a string with both of them in it. Okay, fine. That's what map is going to do for us. Seriously, not enough coffee. Okay, so that's what map is going to do for us. It's going to go through and it's actually going to build and test or build us an array of whatever we asked it out of those things. And so instead of a for loop with a bunch of logic that's stuck inside there that we might have to write over and over again in an application, we wrote one little function and we used map and we were able to build the same thing that we needed to. Okay, apply any function we want. The results get back out of here. So while I used this so far to build a string, again, if I had some other object here, I could do the same thing. I could have rearranged it. I could have made some other object. I could have transformed it in any way I wanted. Let's look at a couple others that are actually kind of fun that people don't use, which would be terribly useful. Sum. Okay? Sum checks the array to see if any of the elements meet the criteria we set. So let's do this. We can reuse the functions that we already wrote up here. And that's where it gets really cool, right? Is that we've actually got things that we can do with filter functions, and we can do the same thing here. So people.sum, where the age is less than 500. When we run that, this. If you could just tell me that earlier next time, that'd be a little bit better. Thanks. All right, so if we do that next time, this time with data that we actually want to put in there, what we should get out of this is true. In other words, there are some items in that array where the age is less than 500. Hey, really quickly, is every item in that array less than 500? Nope. Every item in that array does not have an age less than 500. No loops, no crazy stuff all over. I can reuse it over and over again. And by the way, in an application where maybe I have like 4 or 5 data structures that I'm using a lot or often, I can make a couple of functions that actually work with these. And it turns out I can actually build them. Actually, you know, to be fair, we could go one level further. If we really wanted to, we could say private function generic compare, right? And it would take a field and return a function, right? As a starting point. And we can return a function in here. Yeah, stick with me on this one for a minute, okay? Which is going to do what? Well, we know that we have a person, and we know that we have a field that we wanted to, and we're going to get a number, so I guess we kind of need to figure out how that was going to work. Oh, but we have this sort of concept again, where if we knew that f of x and y could be represented as f of x and y, then this could be represented even more. In other words, every time we need more parameters, we can actually make another function. Which means that we can go back to our code and we can have a little bit of fun and we can say, well, really, if you think about it, saying person.age is less than number is kind of a specialized case of saying any field is less than something else, which means we could replace that expression with another function. So we could have functions that built on themselves. We can have the idea that what we want is person compare, okay? It's going to take a field, type string, and it's going to return a value, and it would return, right, a function that's going to take a person, and again, we'll stick with this whole rest thing. That's going to return a Boolean, okay? And we're going to check if, and it's going to basically return person field. Okay. And then we can start composing these things because now we actually have something that is a person compare, so it's going to take a field. And we can do that in here as far as age goes. So like less than age could actually be a function that we created. So less than age could take, for instance, a field. Let's do a greater age, right? And we can say something like field and number. And we can return a function. Won't take this too much for variables. Okay? And from here, then, what we can really do is instead of greater than age, this can just, greater. We can then say, okay, well, what do we want to compare? Well, okay, again, we need a function that goes to compare what we have one. So person compare returns a function that's going to return a string. Okay? So that actually returns it. And then we want to find out if it was greater than number. And we can vary that inside here. And so on and so forth. Anyway, the point of the exercise is that we can build these compositions of functions by allowing ourselves to go deeper and deeper into creating functions which return functions. And this technique, although kind of foreign to most of us, allows us to build up some syntax that actually can be a whole lot easier than the traditional stuff we've done. This, to me, even though, you might have to put it on some separate lines, okay, when we're all done, but this, to me, being able to say, well, is every person less than 50 or has a first name that starts with June, is actually really powerful when we go through and actually syntactically kind of build things. All right, let's take this and apply it somewhere else. I've shown you filter, I've shown you sum, I've shown you some other things. But this idea of building higher order functions that capture other functions can be used in other places too. Let's take an example here for a moment and we'll just comment these out for right now. And we'll come on down here and we'll take a data grid. We have two of them. So what I'm going to do right now is we'll take the people array and I'm going to put it in an array collection. okay? And it's going to have people in it, which is what we've been working with so far. And for good measure, we won't worry about the filter function yet. We'll put the refresh in so that we can get to that in a minute. But we'll just simply say datagrid1 dot data provider equals array collection. Okay, hopefully not a terribly big surprise to anybody that we get some fields inside of the array. Okay, all right, now we want to filter this guy. Well, the filter function for array collection takes a different signature, and that's okay. We, as you already know, could make functions that do this. We'll just do this one in line for right now, but we can make a function that returns it, okay? So this one's going to return person, and it's going to return a Boolean. It's going to take a person, it's going to return a Boolean, okay? And actually, we'll shortcut this. We'll say that what we want to do is less than age 500, okay? Let's see what happens here. Go run this one. Okay, we get the people who are less than 500 in age. So we reused our piece that we were using for filters, now we've used it with an array collection filter function. Now the thing is that that's fine, but there's always this scenario in an array collection where I have this data grid one and I have a data provider, but I actually want to provide a slightly different data provider. In fact, actually, one of the ones that I run into all the time is imagine that we have two different screens where on screen one, somebody limits the first data grid by a certain number of rows. And then on screen two, when we get there, we actually want it limited by already that same data set, but a little bit more, okay? We want to be able to go a little bit further. But see, the thing is that we want to keep them tied together because if we make a change to the data set in one place, we want them to cascade and carry through. And that's a little bit weird because right now, the data grid only takes one filter function, right? So how do we make the second data grid actually respond or work along with the first one? Now we can do a couple of things. You've already saw that we can use our OR technique, we can use a number of different things like that to work. We could also build this thing right into the Flex framework if we wanted to. And so let's start right into the Flex idea if we wanted to. So we're going to do something right now, we're going to create something called a child collection. This is a variation of something I've created a bunch of times. So child collection, if I spell it right, is going to be an array collection. Okay, it's a starting point. Now, the defining idea of a child collection is that while it's going to be an array collection, it's going to be a child of another array. Okay? So the first thing that we're going to do here is we're going to not take an array anymore, but we're going to take an array collection as our source. Okay? We're going to take another array collection. The way we're going to use that is something like this. We're going to say out here, our child collection equals new child collection of our array collection above. Okay? Now, inside of our child collection here, we will go ahead and we'll do the normal super jump and stuff like that we're going to do, but we're going to internally, this is more efficient by the way, if I correct about something else, but we'll get to that later. Hi, John. So we, yeah, whatever, it's wrong. So, you're going to have to knock me off the stage. All right, so we're going to internally set the list. The list just happens to be how the array collection kind of maps its array list. It's the data behind the scenes. So we're saying basically, hey, we want to share the same list. We're going to do just a couple of little things here for fun. So we're going to do a private variable. Remember, if things are first-class citizens, we can find them anywhere. So we're going to create one called parent function. It's going to be a type function. And what we're going to do in here is we're going to say this parent function equals the filter function from the one that was passed in. In other words, our parent function is going to end up equaling this guy when all is said and done. And then we're going to override the setter for filter function, okay, inside of our child collection. And what we're going to say is, well, when all is said and done, when somebody gives us a filter function, what we're actually going to do is we're going to want to filter something for them, okay? So they're giving us a function. That's what's supposed to be here. What we're going to do is we're going to internally set the real filter function equal to a function that takes an item of type object and returns a Boolean. And it's just simply going to say, okay, I want to say first, run my parent filter function on the item, and also the new filter function you just gave me. Okay? I'm going to return both of those, which means that I can go out here now to the child collection, and I can say, okay, well, my child collection, what I want to do is I want to say, well, the first list was, actually, I don't know those. Hang on a second. Well, the first list was people who are aged less than 500, and that would work. That should come up with Giorgio. That should come up with June here. I want the second list to further be filtered by people whose name begins with June. And what does that mean? Is that now in two different areas of replication, well, maybe because you know why? It's really important to go ahead and set that data provider on the data grid. Because if you don't do that, I promise you, nothing I did is going to matter. All right, so we go through, and now what we actually have is the first data grid is displaying a list of the first set of filters, and the second data grid is further filtered. Now, this delays, and since we're running a little short on time, and John wants me to get off the stage, we'll kind of just explain it in this way. The important thing about this is that these two things are now tied together. In fact, actually, we can probably do this really quickly. John isn't that big. We can probably add a button on the bottom of this one, okay? And that button could unclick. That's fine. Button click handler seems like a perfectly good idea. I think I've actually seen that name used in many, many projects I've been a part of. We could actually modify something inside of one of these arrays, right? So, well, actually, so what we can do is we can modify something inside of one of these arrays. So what I'll do for the moment, just to make things a little bit easier, is I'll take this array collection. I'm going to promote this one up to the top just for the moment. And so we'll take the array collection, we'll make it up here instead of having it defined in the function, just so I can get to it in a second. What I'm going to do though, why I'm bothering to go through all this trouble, is that up here, the last thing I'm going to do for us in our little whatever thing is I will say array collection.addItem. Okay. And what I'll do in here is I'll add a new person. Okay. Now, our new person constructor, I think, takes a first name. It takes a last name. And I think our first filter on there said, well, we wanted something with age less than 500, right? And we wanted a first name. So what we'll do is we'll do an age of 499, just for good true. Okay. So what we have now is an error. Other than that, okay. So when we actually go through and run this thing now, if I got all that stuff here remotely close to right, we will not be able to see the button at all. And not be able to see the button won't help us. But when we add it up here, we've added it to the data grid, but it didn't make it through the filter criteria down there. Okay, no worries. So for right now, let's just go ahead so we can see what's happening, and we'll add it in two places. We'll make sure my name actually works out this way. I guess we'll make it Jennifer. That's a good name, right? So Jennifer will be added now. And in Jennifer, when we add, we'll actually see show up in both of them because of the fact that those two array collections are actually physically the same thing. They're just two different sets of filter functions. The important thing, though, is that while I could have defined them in one piece, by doing it in this way, I actually, if you picture an application model, I can distribute this array collection to all my other views. And those views, when they wish to, without having any access to the original data or knowing how it's filtered, they can simply define their own filter function, effectively taking this data set and further filtering it. Financial system, imagine that somebody on the top decided it was the financial year 2012 they wanted to look at. Every view in the system now gets data only for 2012. When you get to a screen that wants to run a report for a month, it further filters it down by that month. But it doesn't have to know, oh, first I have to filter it by 2012. Now I have to filter it by this. It's ignorant of that fact. We've distributed that or removed that responsibility from every object. And it's because we basically stole a little bit of these techniques. Get it? Questions? All right, see, look at that. Ended on time. It's all good. John, you're up, buddy. Thank you, everyone.
My fancy little